most ambitious high-speed rail project in history is under construction.
It's the most sophisticated railway engineering project ever.
China's two greatest cities, Beijing and Shanghai, will be linked by fast, affordable transport. And the line is set to be a record breaker, the longest high-speed track in the world.
It's the first time that anybody has constructed 1,318 kilometers in one go.
But that's not all. With a previously unheard of top speed of 380 kilometers per hour, the new line will host the fastest passenger train on wheels, pushing the very limits of rail engineering, making the Beijing to Shanghai line the fastest high-speed railway in the world. Beijing, the political heart of China, an Olympic city and the country's capital of culture. And Shanghai, the world's most populous city, home to the 2010 Expo and China's blossoming financial center. Traveling between these great cities today involves a 10-hour train ride on a line built a century ago. That's about to change. Construction has begun on a new high-speed rail system that will complete the journey in under 4 hours. A super high-speed link to invigorate the economies of both cities and connect the quarter of China's population that lives on the route of the line. But to break the 4-hour barrier, the engineers have to build a train capable of carrying passengers at 380 kilometers per hour. A new world record for travel on rails. To avoid disaster, every part of the new railway, from the train to the track, bridges, signaling and stations, will have to be redesigned from scratch. For the designers and engineers of the new line, it's a true journey into the unknown. In a project that must break all manner of records, Chief Designer Jiang Guang has the biggest responsibility of all, the train.
We paid a lot of attention to the design of the train. We wanted the design to be technically excellent, but we also wanted it to represent Chinese culture.
Japan was the first country to break the 200 km/h barrier with its bullet train. The latest version has a curious duckbill design. France broke the 300 km/h barrier in 1979 with its TGVs, a fleet of trains with flat, sloping noses. China's fastest train, the CRH-3, runs at 350, a world record, but it does it with German engineering. By contrast, the new CRH-380 train is an all-Chinese affair, and it needs a distinctive look to match its record speed.
We were thinking what runs fast in the world. Like a horse, it runs very fast. Like a high mountain waterfall, it flows very fast. Like a space rocket.
Jiang told his design team to open their imaginations to create 20 exclusive designs. Today, he's holding a beauty parade to decide the winner. He judges each trainhead design on aerodynamic ability and also on its power to grab the soul.
We finally came to the 5 best heads. I liked them all. They were unique. And after another round of comparisons, One of them became our final choice.
The winning model needs to look the fastest even when it's standing still.
This is our choice from the 20 different designs. It's dynamic. It has a streamlined shape. It looks beautiful. Air resistance and noise are well controlled. The room for the driver and the front proportions are all excellent. We think this is the most beautiful high-speed train head in the world.
Now that the head has been chosen, it's time to get on and build it. One of the hardest challenges is making the train strong enough to cope with the extreme new speed. At 380 kilometers per hour, the air in front of the train becomes so compressed, it's like repeatedly smashing through brick walls. If the head's not strong enough, the pressure alone could rip it apart. More metal is not the answer. The train won't be able to achieve 380 if it's heavy. The solution? Reinforced hollow walls, very strong and very light. And these welded struts increase strength without increasing the thickness of the outer shell. "380 kilometers per hour is faster than a jumbo jet taking off, which has its dangers. Just look at this race car. The design team need to keep the train firmly on the track. They add these bulging shoulders on either side of the head.
那么我们在设计的时候，原来想打算就这条线主要是为了抑制它的驱动升力。对。那么现在是不是达到设计要求了？驱动升力要比原来降低了很多。对，能达到2吨左右吧？嗯。原来设计应该是这个。是可以。司机使这。
These should act like a wing, but an upside-down one, where the air pressure forces the train down, not up.
这就是这个尖的这条线。
These features, like the rest of the head, are gently curved, allowing the train to cut through the air with the minimum of resistance.
长度现在就从鼻锥。
Of course, air isn't the only thing the train head will come up against, and the most vulnerable part of the train, the windscreen, must be prepared for anything. Here at the China National Safety Glass Test Center, they're looking for the world's toughest glass to fit the world's fastest train. Professor Zhang Shuguang is used to testing glass for trains, but usually only up to 350 kilometers per hour. He's concerned that the current high-speed glass may not be up to the added strains of travel at 380, and he's particularly worried about birds.
都有很多的树，那样的话，它这个是
When a high-speed train comes along,
经常会停留在轨道上。
there's no time to escape.
一个列车飞快的驶过来的时候
When the bird takes off,
发现不了，或者它
it hits right on the windscreen.
它已经来不及逃走了。
Zhang secures the first glass to be tested in a sturdy rig. His technicians prepare the projectile, a bird not usually associated with flight, the dead chicken. This 9-meter cannon will give the chicken wings, accelerating it to over 380 kilometers per hour. At 380, the result of the collision is catastrophic. Just imagine that you're the driver sitting behind this. Zhang's concerns have been justified in the most dramatic fashion, and now he's got a fight on his hands. He needs to find a glass tough enough for the job, or the whole project is doomed. "11 countries worldwide have high-speed rail, but none have a line like this. The Beijing to Shanghai high-speed railway is said to be the longest and fastest in the world. It will also feature the world's longest and the world's strongest rail bridges. China has sunk $32 billion into the new line, but this is no vanity project.
I can tell you that on the Beijing to Shanghai railway, every minute saved on the journey means $10 million for the Chinese economy.
The faster the train, the quicker people can get to work. The government wants the new line to give an annual boost of $300 million to the economy. But that means taking a train full of passengers to record-breaking speeds. At the China National Safety Glass Center, Professor Zhang has discovered that standard windscreen glass can't handle a bird impact at the new train's target speed of 380 kilometers per hour. He's hoping his next sample could be the solution. A super thin sandwich of toughened glass panes wrapped around a resin core, specially designed to absorb the force of high-speed impacts.
好了，大家都准备好啊！这是咱们那个最重要的380公里的这个最新的车型的最后一次试验。
There's a lot riding on the test. If the new glass can take the hit, it will go straight into the design for the 380 train.
380，540公里的，这边600了，那边。
Zhang waits nervously for the air cannon pressure to build. The glass seems to have survived, and a closer inspection reveals that there's not a single crack. It's a perfect match for the new train, and means that the train's designers can take another step forward in their dream for creating the world's fastest train. The fastest train on rails today has a top speed of 350. The jump to 380 may not sound like much, but speed changes everything, and the designers had to start many components from scratch. One of the parts that's most affected by high speed is the wheel unit, or bogie. Zhang Hong is in charge of creating the perfect bogie for the new train, a painstaking process of endless tweaks and tests. Zhang has been perfecting his design for 8 years. It's taken so long because of a strange phenomenon called hunting. At high speed, if the bogie isn't perfectly balanced, the entire train can rock violently from side to side, or hunt. Hunting happens because the surface of each wheel isn't flat. It slopes, and the train can swing back and forth between these slopes like a pendulum. But Zhang Hong can't flatten the slopes because they allow trains to turn through bends. It works like this. The weight of a train is thrown to one side as it enters a bend, pushing the outside wheel onto the top of its slope, and the inside wheel to the bottom of its slope. With the wheels running on different diameters, the train is guided into a curved path. Unfortunately, on a straight, the tiniest imbalance can cause these wheel slopes to hunt. And the faster you go, the worse it gets. Zhang Hong's latest prototype has passed every balance test the factory has to offer. But this place is a different proposition. Here there's a test rig that will make or break the new bogie. The Director of Research and Testing is Liu Hongyo.
In today's test, we will increase the speed up to a maximum of 420 kilometers per hour. If there's no big vibrations within that speed range, it means that the test is successful.
Liu starts the test slowly. The carriage needs to stay rock steady on the rig to pass the test. The slightest sign of movement and they'll have to abort, and Zhang will have to go back to the drawing board. It's a nervous time, but it's looking good. The test rig is now up to top speed, and the carriage remains as steady as when it was sitting still. The test is over, and it's a great success. After 8 years of research, Zhang Hong can finally say that his bogie design is ready for the new track. As testing on every aspect of the new train continues in labs across China, the teams charged with building the track have hit a problem. They're having to cross the biggest river in Asia.
I've built a lot of bridges, but this is the hardest.
To solve it, they're going to have to build the world's strongest railway bridge. The first Beijing to Shanghai line was built in 1908. It's been the main route between the cities for over 100 years, but that's about to change. It's being replaced by the world's fastest railway. But for the Chinese to complete it, the world's busiest river has to be spanned. And it proves to be one of the greatest engineering challenges of the entire project. The mighty Yangtze divides China into north and south. At the point where the railway crosses, the river is 1.6 kilometers wide. Every day, nearly 3,000 boats pass here between Shanghai and the industrial zones of the Yangtze Delta. Wen Wu Song has been given the task of spanning this colossal gap with a bridge strong enough to carry the world's fastest railway.
I've been involved in a lot of bridge building before, but this is the hardest. The deeper the water, the harder the task.
To make Wen's job even harder, the Ministry of Rail decided that the bridge should carry 6 lines. The Beijing to Shanghai line, the Shanghai-Wuhan line, and a subway line from nearby Nanjing. Wen was going to have to build the world's biggest railway bridge. His first job was working out what type of bridge to design.
Because the water is so deep here, around 51 meters, and the river traffic so heavy, you'd normally use a wide span like a highway bridge.
Wide-span bridges like this one, downstream from the rail bridge, are ideal because you don't need to build much underwater support. Although perfect for road traffic, they're useless for fast, heavy trains. The best design for the job is a continuous truss bridge, but it relies on concrete pillars to rest on. And with water deep enough to cover a 17-story tower block, the engineers have a massive challenge on their hands to construct them.
Nobody had ever tried to build a bridge like this in 51 meters of water.
Wen's solution is to get his workers much closer to the riverbed using sunken platforms called cofferdams, which in effect are just great big buckets. 80 meters wide, solid steel and weighing in at 6,000 tons, each of these buckets is nudged into position with 5-centimeter accuracy using GPS. They provide a dry, sunken platform to work from, free from the interference of river traffic and much closer to the bottom of the river. Engineers cut holes in the bottom of each bucket to accommodate steel sleeves, which extend down into the silt layer beneath the river. They then excavate holes deep into the bedrock and fill them with concrete for the pillars. Finally, they fill the buckets themselves with concrete, so the bridge can stand on a very wide platform.
It has the same area as 7 basketball courts and can withstand 80,000 tons of pressure and 6 trains running at the same time.
With the platforms in place, the team could get on with building the main bridge structure, using climbing cranes to swing the pieces into position, where they are then bolted together. After 40 months of back-breaking work, fixing the final bolt was supposed to be the crowning moment for the whole construction team. But the weather provided a final twist in the tail. The heat of the day had expanded the bridge so much that the bolt holes didn't line up. They all had to wait for the sun to set so that the temperature drop would shrink the bridge.
We watched as the holes moved slowly together. When they finally matched, the whole site became very excited. Workers were setting off firecrackers and everybody was hugging.
The finished bridge is a man-made marvel in itself. It has the most tracks, the largest span, and the highest load of any railway bridge in the world. But there's one record it doesn't hold. It isn't the longest, and not by a long way. That accolade, of course, belongs to a different stretch of the Beijing to Shanghai line. To save agricultural land, engineers have raised an incredible 80% of the line above the fields on land bridges. This also keeps unwanted visitors off the line. Here, between Danyang and Kunshan, is the longest of all these land bridges. It stretches for over 164 kilometers. That's the length of 4 marathon races, making this the longest bridge in the world by far, twice the length of its nearest rival. Today, Chief Engineer Zhao Guotang is supervising a crucial installation, the slabs that will carry the rails. 430,000 of these precision-engineered blocks are required to finish the line. To keep up with demand, Zhao took the unusual step of setting up factories along the length of the line to produce them. 16 in all. This one at Bangbu is the largest. Its manager, Shi Xiongwei, has his work cut out for him.
按照施工组织要求，现在你看整个这个板，我们现在
都快撑满了哈。
生产了毛坯板16000多块了。这边成品板的打磨，现在也打磨了13000多块。基本。
The problem is, concrete alone isn't strong enough for even conventional high-speed trains to run on. The force of the passing trains warps them. To battle the even greater forces generated by the CRH 380, the factory takes a belt and braces approach. The workers first create a mesh of steel rods. 2 of these grids are then placed inside a mold and covered with concrete. Lying between the steel grids is the second measure, a series of steel cables stretched by almost 500 tons of force. Once the concrete is set, these tensioned cables pull on its structure, making it completely warp-proof. The panels are finished in a precision grinding machine. Lasers guide the polishing stones to a tolerance of 0.1 millimeters. The result is probably the smoothest, strongest, and most accurate track in the world. High speed creates extreme challenges. Curves must be sleeker, components must be made stronger and lighter. But there's one thing that's impossible to upgrade: the driver. At the Beijing Jiaotong University, this virtual lab measures the human factor of travel at 380. In charge of safety is Professor Wang Junfeng. 30 years ago, he was a steam train driver, but a collision with a car changed his life.
We took the people to hospital, but when we got back to the railway, we discovered a severed hand on the track. It was at that moment I realized how important the driver control system is to railway safety.
The key to safety is signaling, and Professor Wang has a computer simulation that shows why conventional systems break down at high speed. At 120 kilometers per hour, it's quite easy to spot the red stop signals. But ramp up the speed to 380, and they're almost impossible to spot. The solution is a centralized computer that collects data about each train's speed and position via a box on the underside of the train that works a little like a swipe card. If a train gets too close to the one in front, details of how hard the driver should brake are beamed directly to his console. This system only works if it receives incredibly accurate information. At top speed, the braking distance of the new train is simply enormous, over 6 kilometers. The slightest error in the recorded speed of the train could result in a bad braking calculation, and the driver overstepping his mark by hundreds of meters. Professor Wang needs a device that's incredibly accurate and incredibly robust. Only one exists, but it's never been tried on a train as fast as the CRH 380.
This is a speed sensor. There's a metal plate with 200 holes inside. Light comes from one side, and there's a light sensor on the other.
The plate is fixed to the axle of the train and turns in time with the wheels. Each time a hole passes the light, the sensor records a flash. The faster the train goes, the faster the rate of flashes. At 380 kilometers per hour, it produces almost 3,000 flashes every second. And Wang's tests reveal that it records perfectly, no matter how fast it's going. As a crucial cog in the new system, it's a huge step forward in safety from the days of steam.
We didn't have any train control equipment at that time, not even a speed meter.
Now
the driver can read all the information inside the train. He can see how far away the target is. He can see where he is. He can receive command for how fast he should be going. Driving is easier, and the train is much safer.
And there's another advantage. Trains can drive closer together. At peak times, one train every 5 minutes filled with 1,000 people will arrive here at Beijing South Station. Like everything else about the line, this futuristic station had to be built to extraordinary specifications to deal with the demands of the new railway. Beijing South is simply enormous. It has a footprint larger than the Bird's Nest Stadium. It was built using 60,000 tons of steel. And this waiting room alone holds 10,000 passengers with ease. The main architects on the project are Stefan Krumik and Zhao Ti Zheng.
The Beijing-Shanghai line has a top speed of 380 kilometers per hour. It's extremely fast, and we wanted the way that people move through the station to be the same: a fast exit and a fast entry.
To deal with the 500,000 passengers expected to use this station every day, they split it into levels, with departures above the railway and arrivals below. This was supposed to keep the extra-wide platforms jam-free in the busiest times, but there was a major problem.
The Shanghai-Beijing line runs very long trains. The trains are 400 meters long, so you need very long platforms for that. And in Beijing, you have quite harsh climate. You have cold winters, very hot summers, you have sandstorms. So we felt the right solution was to create a very big roof to cover all the platforms and create a very contained environment. But the challenge with a big roof is it needs to be supported.
Big supports take up space, but there wasn't any space to be spared. They decided to draft in a specialist, Gorman Ho.
This side is where the Beijing to Shanghai train will stop. About 1,000 passengers on each train. A big pillar here will affect the passengers enormously. So we have to come up with a new solution.
The only option was to squeeze an extremely thin pillar between the train lines. But Gorman knew an ordinary design wouldn't be strong enough. His solution was to fit this ultra-modern building with a very ancient technology.
Let's pretend Stefan is a slim pillar to support the roof. You can see if I pull him, he falls over easily. But if Stefan spreads his legs, it's a lot harder to move him. This is the same as the A-frame. We don't have to add material. We don't have to make it wide. It is very slim, but it meets our needs perfectly. And we can put it between the rails to support the roof.
Beijing South is up and running, but the new line remains empty, and the 380 train still under wraps. Soon the moment of truth will be here, when Chief Designer Jiang Shuguang must reveal his baby to the world. The Beijing to Shanghai line is designed to carry the fastest trains in the world. But before they can take to the tracks, the trains must pass one crucial test for a mysterious phenomenon that can mean catastrophic failure for any construction. The phenomenon is called resonance, and it's a very violent form of vibration, seen here in exaggerated form. It's something that Vice Chief Engineer Ding San San is working hard to avoid.
Resonance is a crucial design concern for the high-speed train, and is something that we spend a lot of time studying.
Resonance is the tendency of objects to vibrate most violently at certain frequencies. For example, this tuning fork always resonates at 440 Hertz. The danger of resonance is the way things behave when you expose them to their resonant frequency. In 1940, the newly opened Tacoma Narrows Bridge in the United States suffered catastrophic damage. The vibration of the passing wind was a perfect match for the resonance of the bridge. The energy of the wind fed directly into the bridge's vibration, making it resonate so strongly that it fell apart. To avoid disaster, Ding designs every part of the train to resonate at different frequencies by carefully selecting materials and the way they're joined together. This is especially important for the two largest components, the body and the wheel bogie. Today he's testing the body. Vibrating hammers are placed at each corner of the train head, and a technician slowly turns a dial, altering the frequency at which they vibrate. When the frequency of the hammers exactly matches the resonance point of the train, it will vibrate very strongly. It's easy to feel, but not so easy to see. So this bottle of water should help. Ding needs the body to have a resonance point higher than 6 Hertz to take it out of the bogey's danger zone. But it can't be too high, or it will interfere with other components. His target today is exactly 17 Hertz. The experiment begins at 13. The team are looking for any telltale signs of resonance. At exactly 17 Hertz, the train head springs to life. Every surface shakes violently, and the whole head buzzes with noise. Ding has found the exact point of resonance, and the good news is that it matches his design perfectly.
The test we did today was a great success. We carried it out a few times, and the result was stable throughout. The team and I couldn't be happier with the result.
It's been a year and a half since production on the train started, and chief designer Jiang Guang has been there every step of the way. Today is a very special day for him.
The new generation of high-speed trains, the 380 bullet train, is completed. Apart from the designers and engineers, nobody has seen it before. Let's witness this moment together. We can see her face now. Very exciting. Isn't she beautiful?
Compared to the old 350 train it's pulling next to, the new train has been built with a longer and narrower head to reduce air noise. The body is rounder for better strength and streamlining. The gaps between carriages are virtually closed for better aerodynamics. Overall, the look is sleeker, faster, and more aggressive.
The 380 high-speed train that you're looking at has the highest design speed in the world. It's also the safest, most comfortable, and the best energy-saving train. We are hoping to produce 500 to 600 of these trains, or even more, to run on the Chinese high-speed railways.
Designing and building the world's fastest railway and the world's fastest train have cost China $32 billion. The team have no doubt it's money well spent. The reason for their confidence is surprising and says much about China in the 21st century. Soon, China's most vibrant cities, Beijing and Shanghai, will be linked by the fastest high-speed railway in the world. China has sunk $32 billion into the project, which will see city-to-city transfer in under 4 hours. Art consultant Zhao Neng is one of the people who's set to benefit.
这种大概是尺寸可以分开卖，也可以合起来卖。
对，组装起来，对，12个一套啊，还有100个一组啊。
或者6个，因为这个我们客户，然后根据售价的。
Her business sources fine art in Beijing and sells it to the new financial elite in Shanghai. But flying between the cities costs her hours of lost work opportunities every week.
If I'm traveling by, for example, by train, that I can still be on the phone and I can still talk to my business clients. But if on the airplane, I'm completely shut off and nobody knows where I am.
The new line also does away with lengthy taxi rides between airport and city, getting people to work faster. The advantages of the new line are clear. What's not so clear is why it needed a new train to run on it. After all, the CRH 380 will complete the journey only half an hour faster than the existing 350 train would. Is just 30 minutes really worth all that effort? Surprisingly, the answer is yes.
If we save half an hour in Beijing to Shanghai travel, we can save around $320 million every year. This is a remarkable figure.
It's also possible that the changes won't just be economic. They could be cultural too.
I think that in connecting these two great cities, one from the north and one from the south, we will start to see their cultures blend. And that will make both cities stronger in the future.
Beijingers and Shanghainese will benefit from the new line. But so will the quarter of China's population that lives along it. 24 stations are being built, allowing families split between town and country to live closer lives. Cities and towns lying near to the line will boom, and new commuter towns will spring up around the new stations.
In the old days, rivers were the cheapest, the most convenient mode of transportation. It is the same today with high-speed rail. I believe this new metal river will bring huge economic benefits and drive the development of society in the future.
The Beijing to Shanghai line is a record breaker on so many fronts. But it's the millions of lives that it will transform that will become its true legacy.